Okay, so let's take a look at Unit 5. Unit 5 is going to be about stuff called exponential functions, which some of you may have studied before. And so let's just look at some examples. We'll just work our way through some of these problems, and you'll kind of see that a lot of these are related to growth rates. Um, so let's see here. One of the things that can grow exponentially is stuff that's related to money. And so this talks about tuition of a certain university. In 1980, it cost $4,500. Okay, so tuition in 1980 was 4,500. And the tuition increase rate, so increased at a rate of about 6% per year. Okay. So that means we can just, in part A, it says you assume a constant 6% rate of increase each year. So what was the cost of tuition in 1981? Well, it would be 4,500 plus the 6% that it went up. So one way you could do that, so in 1981, the tuition, the cost, let's say, cost was going to be the 4,500 plus the 6% of 4,500. Okay, which is really the way that you write this is it's 4,500. That's the initial plus, and you might remember 6%. Another way of writing that is 6 over 100 or 0.06, right? So this is going to be 4,500 plus 0.06 of 4,500. And we can type that in over here on our calculator. 4,500 plus 0.06 times 4,500 equals 4,770. So there we go. Okay, now I also want to write this a slightly different way. Another way to think about this is totally fine, but if you look, then you got to do it for 1982 and you got to do it for another year. And then it says, what will it be after T years? So that's, if you have to do this over and over and over again, you would have to, like for the second year, you now have to take 4,770 and add 6% of that. And that can get a little bit cumbersome over time if you have to do it several times. So there's a shortcut for it. And another way of thinking of this is that the cost in 1981 still, so it will think of it this way. Another way to approach. And really, this is going to be the better way to approach for us. So the cost would be the 4,500 plus the 6% of 4,500. Well, the 4,500 right here is already 100% of 4,500. This part is an extra 6% of 4,500. So really what we're looking at is we're looking at 106% of 4,500. So this is 4,500 times 1.06 equals 4,770. And the way to think about this 1.06, it's the 100%. That's the original amount, right? Original. Plus the 6 extra percent, right? So that's the increase part. Okay. Now that's kind of important. So let's look at 1982 now. Okay. So 1982, what we could do is take that 4,770 and say, so this is, here, let's do this. Actually, let me write it like this. The cost in 1982. Actually, no, let's leave it as just cost. So the cost, I'll come back to this in a second. There's a reason I didn't do 1982. I would say cost at 2. So we'll get there in a second. So the cost is going to be the 4,770 plus the extra 6% of 4,770. Or you could think of it as I'm taking 106% of 4770. Here's the 100% and the extra 6%. Well, that's the same thing as 106% of that, because that's equal to 4770. So I could write this as, let's see here, 106% of 4770. Or I could replace that 4770 with the original, 4500 times 1.06. And then there's this extra 1.06, which is really 4500 times 1.06 squared. So after 1 year, it was 4500 times 1.06 to the first. After 2 years, it was 4500 times 1.06 squared. So if you had to guess what it would be in 1983, oh, by the way, let's type this in, 4500 times 1.06 squared. Okay, 50, 56, and 20 cents. If I asked you for 1983, well, then the cost is going to be, this amount times 1.06 of it, or sorry, yeah, 106% of this, or 106% of this, which is really just multiplying by another 1.06. So it's going to be 4,500 times 1.06 cubed. So I could just take the answer that I got here and multiply it by another 1.06. And we got 5359.57, let's say, since it's dollars, or since it's a dollar amount, a money amount. We'll round it to the nearest penny there. Okay, so then after T years after 1980. Well, this was 3 years after. This was 2 years after. This was 1 year after. Okay, so 2 years after 1980, the cost of tuition is going to be that initial amount times the 106%. However many times you have to keep multiplying by 106%. So in this case, it'll be t times. So we're going to raise this to the tth power. Okay, so that's the answer to this question here, 2 years after 1980. Oh, sorry, that's the answer to the first one, 2 years after 1980. Then it says, what would it be 2 years after 1980 if the rate of increase were 5.5% instead? So if the rate of increase was 5.5% instead, then the cost would have the same sort of format. It'd be 4,500 times 1.0. Well, now it's not 106%. It's 105.5%. So 5.5% out of 100 is the same as 0.055. So this thing would be 105.5%. And then that's raised to the t. Okay, so that's if it's 5.5%. This is if it's 6%. There was one other question. What would it be this coming fall? So this fall, we'll use the 6% model. So this fall, where am I going to fit this? I'll just cram it in right here. So this fall, T would be, let's see, it's 2025 this fall, this coming fall. So 1980 to 2025, that's 45 years. So T would be 45. So let's see what a 6%, so the cost would be 4,500 times 1.06 to the 45th. Now 6% for any 1 year is not too bad. Well, actually it's not great. But over the course of 45 years of that compounding over and over and over again, that probably shoots up pretty high. So let's see, 1.06. And then this button right here that little up arrow looking thing is the power button, to the 45th. 62,000-ish dollars. So 61,940 point, let's say 75. So that would be the tuition, assuming 6% constant rate of increase, right? It's not always the same exact rate year after year. In fact, I think it's slowed down a bit, but in the 80s it was jumping at like 8 or 9% a year, which is a ton. So, okay, let's look at B. B says graph a model for C of T, the cost of tuition, C. So C equals cost of tuition. Tuition in dollars. T is number of years since 1980. And it says again, assume the 6% annual rate of increase. So that's this thing again. That's so instead of y equals, it's C of T equals our initial amount, 4,500, times the 100% plus that extra 6% to the number of years that we have to compound by. How many times do we need to gain another 6%? Okay, and if we were to graph that, now we already have some points. In 1980, which means t equals 0, so when t is 0, we already knew the answer was 4,500. And if you think about it, 1.06 to the 0, remember, most things to the 0 equal 1, except for 0 to the 0. So 1.06 to the 0 is 1. So if you plug in 0, you get 4,500 times 1, which is 4,500. So right here, I'm going to put just a dot here and say that's 0, 4,500. Okay. Then we knew in 1981, that's when t is 1. In 1981, we got the amount 4,770. So 4,770 would be like, I don't know, let's say here. So 14770. When t was 2, C of 2 was, what was that? 5056.20. So that would be, I don't know, like around here somewhere. So 2, 5056. Actually, let me do this. This was 1, what was it? 4770. This was 2, 56.20. When t was 3, we got 5359. So somewhere over here. 3, 5359.57. Now, when you zoom in on just kind of a small portion of this graph, it looks pretty linear. So what we'll do is we'll graph this on Desmos as well, and I'll do some zooming in and out for you. So let's take a look at Desmos. Let me expand this window here. Okay, so we're graphing C of t equals 4,500 times 1.06 to the t. Okay, now you can't see it on here because the scale is way off. Now the y values are going to be in the several thousands. So let me click on this and zoom this way down, the y's. And you can see, oh, look, there's some of the curve right there. And then let me zoom in this way a little bit. And now if you look at it, you can tell pretty well this thing is not a straight line. And it's also not a parabola because it doesn't come back up, right? So this is a special kind of graph called an exponential graph, and it's showing something called exponential growth. If you look right here, right, there's our 4,500, right? Here at 1, I don't know if I can get it on there. Oh, that's 2 already. Down here at 1, there's the 4,770. If you come up to 2, there's our next amount that we said. I think we did 3 also. 45 years would be way up here. Whoa. Look at how fast that thing starts growing. 45 years is somewhere around here. Where is it? 45, right around there. So in another 10 years, you get up to 55. That's not even on this chart. You're already up above $100,000 a year. So you can see these things grow very quickly. Okay. Let's go back to this thing here. All right. So again, this fits something called an exponential pattern. That's the type of model we're looking at. And if you graph enough of it, it looks like this sort of shape here. Right. So, and in general, exponential graphs always kind of do this. It's just a matter of how steep they are and where they might hit, and if they've been shifted up or down a little bit. So, okay. If the pattern had been true before 1980, what was the tuition in 1970? So here's our function. It's C of t equals 4,500 times 1.06 to the t. So if this pattern had been true beforehand, you should be able to plug in t values that indicate prior years. So in 1970, years since 1980, that would be t equals -10. And this will work for that too. We can plug in c of -10, and I'll get 4,500 times 1.06 to the -10. Now, if you wanted to do this without having to do, you remember negative exponents mean the same thing as this. It's 4,500 times times 1 over 1.06 to the 10th. So you could type it in like that, but the calculator can handle this. So let's go ahead and dig up that calculator again. So it's going to be 4,500 times 1.06 to the -10th. Enter. So it's 2512.78. So in 1970, that's how much the tuition would have been. Okay, now it says in part D, not that this ever actually occurs, what would change if the tuition actually decreased by 6% each year? Okay, so here's the model that we had was with the increase by 6%. We got this. We got C of t equaled the initial amount times 100 plus the 6%, right, to the t. So if it decreases by 6%, you're not left with 106% of the original. You're left with 94% of the original, which is 1 minus 6% to the t. So you could think of this instead. I tend to just go straight to this line. 4,500 times 94%, which is 0.94 to the t. So this would be the model for a decrease. In textbooks, for exponential growth, or in this case, decay, right? Because if you take 94% of something and then 94% of that and then 94% of that, it decreases over time. Oh, by the way, a graph of that would look like this, right? Just going downwards instead of upwards. In textbooks, you often see that this exponential growth function, it's often called like a population function. You'll see it as population over time is your initial population, and then 1 plus or minus the rate of growth or decay, depending on the problem, to the number of time increments, usually years. So this is often how you see it formatted in texts or like online and stuff like that. But really, we're just using a specific form of that. And in this case, it's for a 6% increase or decrease of tuition. Okay. Hope that helps a little bit and makes some sense.